Hello, and thank you for coming to my presentation. It is about sewer submergence in groundwater and what that implies for water reuse, specifically in the South Truckee Meadows regarding arsenic concentrations. I'm Alexa Terrell, and I'm a hydrogeologist at McGinley & Associates, and this study was done in partnership with Washoe County Community Services Department. So McGinley & Associates worked for the South Truckee Meadows Water Reclamation Facility. McGinley & Associates, we were formerly Interflow Hydrology when we started this study. And so the reclaimed water from the South Truckee Meadows Water Reclamation Facility is used for landscape irrigation throughout South Meadows. And the irrigation arsenic concentration standard is 0.1 milligrams per liter. Meanwhile, the water provider for Reno is Tumwa, and they had an arsenic concentration for their water of 0.0094 milligrams per liter, which is well below drinking water and irrigation water standards. But over time, the water reclamation facility was noticing their influent into their facility was creeping up in arsenic, and eventually exceeded the 0.1 milligram per liter standard. So what was happening between the input into the system and then the input into the water reclamation facility? A study done with Carollo engineers and McGinley & Associates found that the manholes, which were made of concrete blocks, were actually leaking in the groundwater was able to enter into the sewer mains. So what are the challenges we are facing? First, we want to identify the arsenic concentrations in the soil and groundwater around South Meadows. Next, we will figure out the submergence of the sewer manholes. And then the last part, we'll understand the long-term water level trends and understand what future mitigation measures we may encounter. So this is a general location map of South Reno. And in the orange box, it shows the South Truckee Meadows Water Reclamation Facility. And the blue dots are the monitoring wells we constructed while we were doing this study. And the red box shows our study area. And it's surrounded by the Huffaker Hills to the north, the Virginia Range to the east, and Steamboat Hills to the south. So this map is the same area as the last one, just showing the groundwater contours. And you can see they're moving northeast. The groundwater is moving northeast through South Truckee Meadows. And the Huffaker Hills and the Virginia Range are actually acting as a barrier to groundwater flow there. And this means that there's reduced groundwater flow through the north. So the groundwater is being converted into surface water, or it's being evapotranspirated in the area before it can leave. So what was South Truckee Meadows before it became a neighborhood? Before the urbanization of South Truckee Meadows, it was ranch and farmland, which was importing Truckee River water through Steamboat Ditch, and that was adding to the groundwater flow through the area, and in turn increasing the output through Steamboat Creek because of increasing flows. But in the meanwhile, there's this deep geothermal inflow through the fracture zone, the fault zone and the fractures in the deep bedrock below South Truckee Meadows, and you can see that in Steamboat Springs. There's a lot of geothermal activity there. And this high concentration of minerals and salts in the geothermal water is adding to the salt and minerals in the aquifers, which in turn, when they're evapotranspirating, they're adding salt and minerals to the unsaturated soils there. And this geothermal water has been active for 1 to 3 million years in the area, so it's had a long time to build up. So in the late 1990s, residential and urban development began in the South Truckee Meadows, and in the early 2000s, the South Truckee Meadows Water Reclamation Facility was built. This graphic shows a conceptual aquifer system in the South Truckee Meadows, and you can see there's still the geothermal outflow coming up through the fractured zone in the bedrock. Deep down, I think it's about 1,000 feet-ish to bedrock around the South Truckee Meadows. So what is happening here? So with the lowering of farmland and ranch land, we're getting less imported Truckee River water, but at the same time we're still having the same geothermal input into the system, which is migrating upwards as there is a bottleneck in the north South Truckee Meadows and nothing can flow out of it, or very little. And now there's less dilution in the aquifers and less volume going through Steamboat Creek out of the South Truckee Meadows. And this leads to, of course, the building up of more salts and minerals. But now we have landscape irrigation for housing and residential buildings and commercial buildings, and this is actually allowing leaching of these salts and minerals back into the landscape, but it's not enough water to flush out the aquifers. It's just ending up in the shallow aquifer now. So how are we going to quantify the arsenic and groundwater levels? First, we took hand auger soil samples of the unsaturated zone, and then while we were drilling monitoring wells, we did split spoon soil sampling, and we took water samples from the monitoring wells after we had developed them. And here is the location of all of our hand augered samples and wells. You can see the hand augered samples are the light green dots, and the monitoring wells are all the blue dots. And in addition, there was 3 Washoe County wells that were previously constructed in the northwest of the study area. So here we are out hand augering some soil samples, and we took 31 samples and got them analyzed for leachable arsenic, and we classified all the soil according to USCS soil classification standards. Meanwhile, also drilling monitoring wells. We drilled 31 monitoring wells in total, 27 shallow monitoring wells, which were screened between 5 and 10 feet below land surface, and then 3 deep paired monitoring wells corresponding with another shallow monitoring well, which were generally screened between 15 and 20 feet below land surface. Here's examples of some of the soils we encountered in the study area, and we sent all the unsaturated soils to the lab for analysis, also for leachable arsenic. So we also had to develop our monitoring wells to get rid of some of the sediment in the water, and then we sampled them and field filtered them and took them to the lab. And then, of course, for the 15-month period of our study, we monitored monthly the water levels of the entire monitoring well network. So, what did we learn? We discovered some water level trends over time. We were able to determine the submergence of the sewer manholes, and we're also able to understand arsenic concentrations in soil and groundwater throughout the study area. So in 4 of the monitoring wells, we put transducers, which were recording daily water levels in around this central part of the study area. You can see the little map in the box, and the colored boxes correspond to the water levels in the different wells. And what we discovered was there's obvious responses to large precipitation events, like in the winter. You can see in December 2019, a little spike in all of the wells, and some of the summer you have summer thunderstorms and you get a few spikes throughout. But what was more interesting was that over summertime, when there's not much precipitation, we would expect more of a groundwater decline, but it was relatively flat for all of our wells until like November, which indicates that there could be recharge from irrigation, from the landscape irrigation. So, I mean, around November is when people are shutting their irrigation systems off, and we finally see a little dip in MW12. And also we examined the Washoe County water levels, which they had been monitoring monthly since October 2011, as you can see here. And you can see them in the northwest corner in the little map at the bottom of the screen. So Washoe County 1 in the green is showing some large fluctuations for each season. You can see it's higher in the winter and lower in the summer. Whereas Washoe County 3 in the blue is hardly showing any fluctuations. You can't even make out the winter, except for maybe in September or 2016. So what that could mean is if you look at the location of Washoe County 1 off into the northwest, it's in a more industrial area. There's probably a lot less landscaping in that area, whereas Washoe County 3 is right in the middle of South Meadows residential area, and it's even right next to Comstock Park. So shows that maybe the irrigation through the system is preventing the high seasonal fluctuations we're seeing in Washoe County 1. And then we used Kendall's Tau to overcome the seasonal effects, and so we could look at long-term responses in the groundwater levels. And we determined that Washoe County 2 and Washoe County 3 both show statistically significant trends with increasing water levels over the past 8-year time. And this map shows the potentiometric surface, the groundwater surface in South Meadows study area based on all of our monitoring well data. And you can see it's flowing northwest, or northeast, sorry. And also you can see there's some parts where it's a trough and some parts where we have groundwater mounding. And what this means is there's a lot of interconnection between the groundwater and the surface water in this area. And here we have sewer submergence we were able to calculate based on the depth to water we found and how deep the manholes were within the study area. So the blue labels are the submergence of these manholes, and the deep purple shaded area is the highest submergence within the study area, whereas the light blue is little to no submergence in the study area. So the highest levels of submergence in the north central area, as shown in this purple box, and the south central area. And the north central had 9.75 feet submergence, and the south had almost 8 feet of submergence. But unfortunately, this corresponds with our arsenic and groundwater concentrations. And you can see over the entire study area, our arsenic is actually above the irrigation standard for arsenic of 0.1 milligrams per liter, with the exception of MW26, which is in the south. And you can see it's kind of maybe corresponding to Steamboat Creek. So, you know, that could be because of the upward gradient of water coming up and getting evapotranspirated. This map shows the soil leachable arsenic concentrations within the study area. The highest part is in the north central part, similar to the groundwater. And overall, we have areas that have up to 46.5 milligrams per liter of leachable arsenic in the soil. So it's showing there's still plenty of arsenic that could be leached into the shallow groundwater. And here we have the groundwater concentrations we took and the manhole sample arsenic concentrations that were taken by Carollo engineers in 2018. And you can see the green labels show water in the manholes that is less than the irrigation arsenic standard, so it meets the irrigation standard. And then the yellow, orange, and red labels indicate increasing concentrations of arsenic within the manholes sampled. And now we'll compare that to the submergence in groundwater. As you can see, the very high levels of arsenic in groundwater and some of the arsenic that is found in the manholes corresponds to the sewer submergence in the study area. So here's a conceptual figure of all of our results. And you can see the soil has the highest level of arsenic, whereas groundwater still has high arsenic, and the deeper groundwater has about half the arsenic of the shallower monitoring wells sampled. So it's just going from higher to lower, and this could have been over time. So what did we get from this study? The sewer submergence is a primary indicator of arsenic entering into the manholes. This makes sense. More submergence equals higher pressure, and that pressure is entering in through small leaks within the manholes. And unfortunately, the areas of higher arsenic in the groundwater also correspond to high submergence in the groundwater. And urban landscaping could be exaggerating this effect by leaching more of the arsenic and also increasing groundwater levels over time. So what were we going to do? Washoe County took our guidance for where the highest arsenic and submergence was, and they lined those and sealed those manholes, which is along that narrow corridor, which really had high submergence. And recently, the influent into the South Truckee Meadows Water Reclamation Facility now meets the irrigation water standard for arsenic, which is less than 0.1 milligram per liter. So there was success. And this shows science influencing policy can lead to better water resource utilization. Some references. Thank you for participating in my presentation. If you have any questions, please come to my live Q&A after this session.